Hey everyone, it's Ben. In this video, I want to do something a little different to what you normally see on YouTube. In the tech field, I think you see a lot of explainer videos, and I've even made one myself. But I feel like there's too many explainer videos out there. You can find 20 different videos for any technology that you want. What I think I can bring to the YouTube community is storytelling. The story that I want to tell today is about the evolution of data at a company. How does a company go from having zero data and making decisions day to day just based on the human experience and gut feel, all the way to a company that is making decisions based on statistical analysis, experimentation, the scientific method, right? These are all the things that we would say define a data driven company, but how does that actually happen? How does it come from nothing? So in this video, we're going to create a fictional company and imagine it starting from zero and then evolving step by step all the way in its path towards data maturity. This is something that I've seen in my career a lot, not all at a single company, but I've seen companies that are at the very pinnacle, and I've seen companies that are somewhere in the middle, and then seen companies that have absolutely nothing. And so painting it all in one picture, I think, will be very useful because it'll give us a cohesive story to tell, and it'll give us something like a roadmap. So as we're telling this story, you may see where your company is at along the way. This can give you some knowledge and some insights as to how you got there or where you might be going in the future. So go ahead and join me, and my cat's here, and we're going to talk about data at a company. Chapter 1, the Tinkerer phase. So this first phase or chapter of our journey is what I like to call the Tinkerer phase. I call it that because these people are not really engineers. You don't have data engineers or data analysts. People with data is in their title. But what you do have is people with other titles tinkering with data and doing data-driven decision making with very minimal set of tools. So let's get an example. Imagine you are a supply chain manager at a factory. Your job is to manage all of the vendors that give you raw goods, and then you manufacture something, and then you export the out result, right? Really easy. Pretend you have 10 or 15 years of experience in this field. You know this like the back of your hand. But at some point, you're going to think that something about the factory is not running as efficiently as it could. We may be buying the same part from two different vendors, or we may be overspending on something. What you need to know is how much. You need to know the magnitude, and you need to know specifics about this problem that you have a hunch about. So what do? You don't have a ton of time to go sit and review every single thing that we have in the company. So you go find an intern or a subordinate, somebody who has a lot of free time, who you know is pretty flexible, they can do anything, and you give them this task. Hey, intern, go export all this data from our ERP system and make me a little chart that shows what products we're buying from what vendors, and then give that to me. Especially highlight any time we're buying the same part from two different vendors, especially if the cost goes more than $10,000 in a month, let's say, because that's an indication that we could consolidate and save some money. So they run off, they do that, they probably export all the data into Excel files on their own laptop, and then they use some random scripts to aggregate it and munch it all together, and then they get you the output, and they say, oh yeah, actually, you're right. There were 3 products that we have 2 different vendors for, let's go ahead and consolidate them. Congratulations, you're now a data-driven decision maker. You have started your company on the path to data maturity. Whether you like it or not, this is going to be your thing from now on. You're now the data guy. So that was a great example, but let's get a little bit more formal and talk about some key characteristics of data at this phase. 1. When we say data here, we probably just mean files that are being thrown around people's laptops. This is Excel files, CSV files, things that you just get from people or from other systems like ERP systems or Salesforce or something like that. You get the data exported from these systems, sit them on your laptop, and then all your scripts run there. 2, the data processing itself is just happening on someone's laptop as well. The files come into your laptop, and you probably wrote a bunch of Python scripts, Excel macros, anything, whatever it takes to actually process the data. It's just happening on somebody's laptop, which is great because you can edit it whenever you want, and you can fine-tune it and play with it. This is the tinkerer phase. We don't need anything crazy. 3, nothing is automated. One key characteristic of this phase is that if you want to change something, run this thing again with new inputs, then you have to just download the scripts again, download the files again, and then run it with new inputs. There's nothing that you can do to automate this unless you happen to have a scheduler on your laptop. But because everything's running on someone's laptop, there's no way to schedule something to run at any point in time. And that's the tinkerer phase of the data maturity journey. Is it really unreliable? Yes. Is it duct taped together? Yes. But does it work? Also yes. So that's the tinkerer phase of the data maturity journey. Is it duct taped together? Yes. Is it unreliable? Yes. Does it depend on the one guy in your company that knows how these scripts work? Absolutely. But it's worth calling out that there's nothing wrong with being in this phase of your data journey. As long as your needs of data are relatively infrequent, you have enough experience in your line of business that you don't need a bunch of graphs and dashboards to make decisions day to day, then you could exist in this phase for years, if not decades. But if you find that you need more and more dashboards to make decisions, or the decisions that you're making are way more targeted and specific, then you may find yourself going to the next chapter of our data journey. Let's talk about that, chapter 2. Chapter 2 is the cloud migration, and there's two things that can get us here: fear and scale. And if you're an engineer, those are the same thing. So what happens is you start having more and more data sets, more and more scripts, and more decisions in your day-to-day that are being powered by these scripts and data sets. And you realize at one point, they're still just running on somebody's laptop. What would you do if that person takes PTO? What would you do if that laptop spontaneously combusts and you lose all of the data and all the scripts? You're going to lose a really big part of your decision-making capabilities just in the blink of an eye. So fear will drive you to pursue this cloud migration. The other thing that can happen is you actually have so many dashboards, so many data sets, and so many scripts that your intern can't handle it anymore. Either they ask for a raise or they ask for you to hire 3 or 4 more people. But 3 or 4 people can't work out of one laptop. You need a way to share the load, to have multiple people doing this kind of work. Whichever one it is, they both lead you to the same end result, which is a migration from your laptop to the cloud. The actual cloud service you use here can be one of many things. In some cases, you can just spin up a VM in the cloud and then just go from a laptop to a VM, which is totally fine. In other cases, you can just spin up a cloud SQL server and have everybody work out of the SQL server with some connection string and a local IDE. And in the most extreme case, you can go to a cloud-based data platform, something like Microsoft Fabric, Databricks, Snowflake, Amazon Redshift. There's a million of them out there. But whichever one it is, it just depends on how much you're willing to spend and how much complexity you're willing to put into the system. So what are some key characteristics of this cloud migration step? First, all the data that used to be in files on somebody's laptop is now going to be moved into tables in this cloud platform. They can be tables on a SQL server or Delta tables in Databricks, Snowflake, Azure, whatever it is. 2, the things that process those files, the scripts, are also going to move to the cloud. So you're going to have SQL scripts running in this SQL server, or you're going to have notebooks if you're using one of the more modern data platforms. Third, you're going to unlock automation at this point. Because everything is running in the cloud, you can have schedulers that trigger things in response to specific events. You can run all of your update jobs every single night. You can run whenever new data comes in. You have the ability to automate these data pipelines so they run without somebody sitting there and clicking buttons to run them manually. And lastly, because the data is available in the cloud now, it becomes more integrated into your company's day-to-day processes. You may have regular reports that have to go out to stakeholders in the company. You may even have applications that use these data sets day to day. You may have customer-facing dashboards that the customers themselves see and they pay money for. The data is now becoming a part of your company, and this is the first step where you could say you have a data platform, right? It's a relatively simple, not very mature data platform, but it is a data platform. It's got data in it. And just like chapter 1, depending on the size and scale of your company, this setup can take you really, really far. You can get up to hundreds of data processing pipelines, thousands of tables, and that could be just fine for your company, depending on what you do. What is going to take us to the next level, though, is starting to hit, again, some of the scaling limits of this setup, or some of the evolving complexity of having data be baked into your organization. With that being said, let's move to chapter 3. Chapter 3 is the Dunbar phase, and this name probably requires a little explanation. Now, Dunbar's number is a phenomenon in social sciences that says there's natural limits to how large a group of humans can get, just because our little brains are not that smart and they can only hold so many connections with other people. So, on average, a human living in this world probably has something like 3 to 5 best friends or close family members, and then maybe 15 friends that are close friends, maybe 50 friends, and then maybe 150 acquaintances. These numbers show up a lot in different areas of the world because they're naturally baked into the way that our brains are wired. So this phase is called the Dunbar phase because I believe, at least, and experience has shown, that it is really impossible for more than 5 to 10 people to have access to the same database at any given time without stepping on each other's toes and eventually wanting to rip each other's throats out in a morning stand-up. The whole point of the Dunbar phase is logical separation. If you have something like 20 to 50 data engineers at your company, they're going to want different workspaces where they can keep all of their lines of work separate from each other. And how you do this is obviously going to change based on what you actually used to build your cloud platform in the first place. But just like the other chapters, let's outline some of the key characteristics of what happens here. First thing that you do, what I just mentioned, you find a way to logically separate all of your data engineers into different domains. If this is SQL Server, you can use different schemas or different databases entirely. If this is Databricks, you can use different catalogs, different workspaces, whatever it is. Second, you're going to want some kind of access control system. So if somebody new joins the company, they don't have access to all the data in the company, just the data that's related to their job. Third, this is where a lot of companies start to build data platforms. When you have so many different data teams operating in your company, it becomes really prudent to create a platform team to build common tooling and common infrastructure for all of them. That way they're not all reinventing the wheel and spinning up their own infrastructure because they're all doing essentially the same thing, just in different domains. And fourth, we call this data literacy or data enablement. Now data is becoming such a big part of your company's core identity and culture that you're going to start wanting to train people across the company. So here we'll start having things like data literacy courses. You may start to see people across the business who are not data engineers want to learn more about data, how to use it, how to adopt it. A lot of times we build these enablement and training programs at this phase as well. And if you've done all these things, you've logically separated your data into different workspaces. You have defined access controls that are appropriate to what everyone's doing. You have a platform team so you don't duplicate infrastructure. And you've started training people across the org so that even business people that have nothing to do with data are at least literate enough to understand it. You're well on your way to data maturity and being a really data-driven organization. You've done a great job. And many companies stop here, but there is one more chapter for those that are really at the peak of their data maturity journey, and let's talk about what causes us to get to the next step. The last chapter of our journey is called governance, and governance means a lot of things to a lot of different people. I personally think the best way to explain governance is to explain the problems that exist that governance seeks to solve. So, in the last chapter, we painted a picture of a company that has a bunch of different data teams running in different lines of business. Sales has a data team, marketing has a data team, manufacturing has a data team, supply chain. There's tons of different data teams working in this org, solving the needs of their line of business. One thing that can happen really quickly is you may log into the central data dashboard, look at Power BI, and see, wow, there's like 1,000 different dashboards here. And we definitely don't do 1,000 different things. How is it that we have this sprawl of data assets? What even is this? What's being used? Nobody really knows. So this is one of the first problems that governance seeks to solve, the management of data assets themselves. It's very common for people to create tons of data pipelines, tons of data sets, and tons of dashboards, and then forget to delete them when they're not in use. So governance will standardize the management of these data assets and start to add things like lifecycle policies. Hey, if this dashboard hasn't been touched in 5 years, why do we still keep updating it every day? Good question. Governance is the program that solves that. Another thing that governance can solve for you is standardization of semantics. I'll give you an example for this one. Let's pretend that I'm a salesman in B2B sales, and I just landed the biggest contract of my career. It is a 3-year contract with company X, and it's for $9 million. I'm ecstatic. So I go into my sheets and I log that I made $9 million in 2026. So on a dashboard, it's going to show that we made $9 million in 2026. Now, I go over to my friend in accounting, tell them that, and they say, no, actually, you didn't make $9 million in 2026. You made $3 million in 2026 because this is a 3-year contract. You have to amortize it. You actually made $3 million for the next 3 years. So this is a difference of semantics. When accountants see sales, they see how much money are we going to get each year. When the salesman says sales, they're looking at how much value did we close on this year. So if you're some high-level executive and you see a sales dashboard, you have to go ask, whose version of sales are we talking about? And that's just really confusing, especially there's dozens of departments in the company, there's dozens of different terms like this, and the dashboards are all correct in their own version of reality, but there is no single unified truth that says this is what sales means. So this is another thing that governance does, is we usually create catalogs and start to standardize some very specific terms that say, hey, when we mean sales, we mean specifically this formula, and this is how you're supposed to use it. And the last thing with governance is compliance and security and regulatory things. If you have medical data, then you are beholden to HIPAA and all the different EU regulations for medical data. If, like myself, you work in the nuclear industry, there's a bunch of regulations on what you can do there. So at some point, you have to track all of these different policies that apply to your data and actually make sure that they're enforced. So this is also governance, right? So that's governance, or at least a very basic view into governance. I'm definitely not going to go into everything governance here in this video, and honestly, very few companies even get this far, and they're all aspiring to be better and better about governance these days. But if you made it all the way through this video, thank you very much. I really appreciate it. I hope you learned something. I definitely did, at least. Just making the script for this video was super helpful for myself. Have a great one, and I will see you in the next one.